So these questions are simply asking for the area that lies either left or right or between some z-scores. And we know when we look at our z-charts that our z-charts have the z-score column over on the left, and then all the numbers that are in the chart represent the percentiles, or the area to the left of that z-score. And I think I'm confident after watching you that you guys feel pretty good about that. So when I give you a question like one of these questions are really are pretty easy because you don't really have to do any work. You don't have to calculate a z-score. You already have it. I would just recommend you draw a picture and show me what the area looks like. So, for example, this first z-score that's negative, we discussed that the mean is always in the middle of a normal distribution, and that corresponds to a z-score of 0. Any negative z-score would be to the left of that, so maybe z equals negative 0.58 is over there. We draw a line up, and we shade that in. Okay, and we go look that up in the chart. So negative 0.58, it's down here, negative 0.5. Go over to the 8. Oh, that's all right, that's incorrect. Go over to this 8. There we go. 0.2810 is most likely what your chart says. 0.2810. And that's it. That's the area. Now, you should know that the word area under a density curve has some synonyms. Okay? So you could say proportion. That means the same thing as area. You could say percent. Right? Just write it as a percent. Or you could say probability. Those three things are all synonymous with finding area under a density curve. Okay? If you look at a problem like 2, they want the area between two z-scores. I'm going to discuss a couple of ways you can look at this. Here's z equals negative 1.16 and z equals 2.71. They want the area between. Okay? If we think about how the z-chart works, the z-chart only gives us area to the left of a z-score. So we could look up this little area pretty quickly by going to negative 1.16 on the chart and finding that number. We could also get this whole red area. And that's the same thing. You'd look at the chart, but you look at z equals 2.71, and you get answers for those things. Okay? So that's just like what we looked up before. That. So the red area is 0.9966. Okay, so we look up that area. This area here turns out to be 0.1230. And then the blue area that we want is just going to be 0.9966 minus 0.1230, or 6378.8736. I want to make a comment about this question because this is the first time that if you start to notice the symmetry of the graph, which as I was talking to some of you did, you can actually speed this up a little bit. Okay? So let me redraw that picture and show you something. Another plan for finding this area, z equals 2.71, z equals negative 1.16, could be this. We know we want this green area in the middle. So what you can do instead, if you wanted, is find that area in that tail, find that area in that tail, and then subtract it from 1. Because we know the total area under the normal curve is 1. Okay, so this one we already know. This turns out to be 0.1230. Okay? The chart will not give us the area above 2.71. So we know what we could do. We could look up 2.71, and we know the area to the left from before, up here, was 0.9966. But here's a fun thing you may not have thought of. How does the area, this is the question I want you to think about as you're watching this, how does the area above z equals 2.71 compare to the area below z equals negative 2.71? Right? They're the same. So if we know that, what we could do is we can go look up z equals negative 2.71. If we do that, negative 2.71, here's negative 2.71 is 0.0034. So this area, and that tail, is 0.0034. Well, because of symmetry in the normal distribution, that tail is also 0.0034. And my promise to you is if you do the following, that means, by the way, this blue area is 0.0034. If we do 1 minus 0.1230, that's from here, minus that number, 0.0034, you get 0.8736. That's just a fun thing to keep in mind when you proceed with these kinds of questions. It's important when you see a new problem to ask yourself, am I being given a z-score? Am I being given an observation or an x value? Right? Which in my mind are the same type of problem. We'll explain why later. But versus a problem where they give you the area and say, hey, what z-score is it? Or what observation goes with that area? So you look at this problem, they're saying find a z-score so that the area to the left is 0.10. So in this case, what we can do is we can draw a normal distribution. We have an area of about 10%, which we know would not make it to the median or the mean. So we know we're down in this lower tail, and that the area in that tail is 0.10. What we're being asked is, hey, what z-score would get us that area? So that means we go back to this z-chart, and we go looking for an area of 0.10. And if we do that, you look around for a little bit. Let's see where it is. Here's some, look in the negative 1.3s over there. Here's a good one. Right here, I think that's probably the closest number. 0.1003 when rounded correctly. That would correspond to a z-score of negative 1.28. Okay. So this turns out to be negative 1.28 is the correct z-score. Okay? And the only thing that gets a little bit trickier, maybe, is if you look at a problem like 4, for example, find the z-score so that the area to the right of the z-score is 0.33333. So we draw the normal distribution. We want the area on the right of our z-score to be a third. So that z-score is going to be over here somewhere. This is a z that I don't know. And I want that area in there to be 0.3333. Well, we know we can't look that up in the chart because the chart area is only to the left of our z-scores. So we just need to ask yourself what this blue area is. That's 0.6666. Okay? And then you go back to the z-chart and you look for something close to that number. And I don't know, maybe this right here. A z-score of 0.43 does the job. Okay? So that's here. So z equals 0.43. Okay. So this question reads, the scores of a reference population on an intelligence scale for children are approximately normally distributed with a mean of 100 and a standard deviation of 15. First question asks us what score would correspond to the 50th percentile. Well, any symmetric distribution, the 50th percentile is the median and the mean. So in this case, it would just be mu equals 100. And we know that because the area to the left is 50%. Don't forget, we reviewed that a while ago, but that the median is sometimes called the equal areas point. Okay? Mean, sometimes referred to as the balance point. And in one of the prior videos, we discussed how to find those things. Okay. B. I'm going to put a star next to B. To think carefully on this one. So a score in what range would represent the top 1% of scores? And this is obviously where we all desire to be. We want to score well on our measures of intelligence. So here's our normal distribution. And we want to be in the top 1%. That means you want to be in this upper tail. and only 1% of the population is going to be there, or 0.01 is a decimal. Okay. So this question is sort of, I'm going to call it a backwards question, because we've been given the area, and we're saying, hey, what score did the person need on the test to be within this top 1% of all area? Well, remember, anytime you give an area, you are really also given a z-score. You're just going to have to go looking for it. Have this realization first that that green area has to be 0.99. And now we're looking for a z-score to go on the bottom of this chart. We need a z-score to go there that would catch 99% of the area to the left. So let's go looking for that. So here's our z-table. We're looking for 0.99. And if you look, here's the number, 0.9901. That's about as close as we get in the table. Corresponds to a z-score of 2.33. Okay. So that means the z-score is 2.33. Or we could say this. If we want to be in the top 1% of the people who took this test, we would need to be at least 2.33 standard deviations above the mean. Well, we can convert that to a score by using the z-score formula. We know that z equals x minus mu over sigma. Or in our case, 2.33 equals x, which we don't know. And we're not surprised about that because that's what they're asking for. They're saying, hey, what score are we looking for? The mean, which is 100, which is given to us, and the standard deviation, which is 15. So all this requires is a little algebra to solve it. Most likely, you cross-multiply first. That's what some of you would probably do. X minus 100 equals 2.33 times 15. X equals 100 plus 2.33 times 15, which means x is about, so if we solve this, we get an x value of 134.95. I'm not sure about this test. It might be possible in this test you can only have integer values for scores. So let's say 135. So we finish this question by saying that if x is greater or equal to 135, then we are in the top 1%. That's what it is. So I'll just briefly mention in question C, I'll just say this, that we'll find 110 on the distribution. We know 100's in the middle, so 110 is to the right of that. They're saying what proportion. It's the same thing as saying what percentage or what's the probability. Has a score below 110. So really, we're looking for that area. And you'd love to use a z-chart. We just need to know a z-score first. So z equals 110 minus 100 over the standard deviation of 15. So that's going to be 10 over 15, or 0.666. We can look that up on the z-chart and get the area to the left. That would be the answer to our question. All right? So these questions, once you use the z-score formula, are exactly like problems you did earlier in the packet. They're exactly like all of these, or these. They're really the same thing. You're just working first to find the z-score. Okay? So let's finish off here, just so we're clear. We found the z-score of 0.666. What we would need to do is go back to that z-chart. The z-score of 0.666, which is what we have, is right here. Here's 0.6. And we'll go across to that. So we'll trace it across. And we get an area to the left of 0.7454. So what that means is this z-score corresponds to an area of 0.7454. That's also the area to the left of the z-score, or the 110 that corresponds to that z-score. So again, if you see the word proportion in here, or probability, okay, or percentage, any of those numbers mean that you're going to have to go look in that z-chart and get the area. Okay, stopping at the z-score would not be good enough. All right. let's take a look at this last problem here. You can be asked questions in sort of a clever way. So here we go. They're telling us that says suppose that the weight X in pounds of a 40-year-old man is a normal random variable. Now, we haven't seen that language before yet, but that's the same thing as saying that the weights are normally distributed with a standard deviation of 20. Right? So we know sigma is equal to 20. We know we have a normal distribution. And you might be a little surprised at this point that they haven't yet given us a mean. All right, so let's read. Maybe it's coming. If 5% of this population is heavier than 214 pounds, what is the mean mu of this distribution? Okay, so you'll notice they're asking for the mean, so that's why it was missing. So we're just going to put mu in the middle here. We don't know what it is. What we do know, though, is that 5% of the population is heavier than 214 pounds. So heavier means we would be to the right of 214, and that would tell us that 214 needs to be somewhere over here with an area above it of 0.05. Okay. So what can we do? Could we get the mean? Well, like I said earlier, if you know the area under the curve, then you do also know the z-score. You just have to go look it up in the chart. Remember, the z-score chart only works with area to the left. So this area here, the green area, is 0.95. So we're going to go looking for a z-score that catches an area of 0.95. Now, I'll save you the time. I think if you look that up, you're going to get z equals 1.64 or 65, depending on how you rounded it. I'll accept either one. Okay? So what we know is that the observation or the weight of 214 corresponds to that z-score. We can write out our z-score formula, which is z equals x minus mu over sigma, or in our case, 1.64 equals our observation of 214 minus the mean. Now, I shouldn't be surprised by the fact I don't know that. That's what the question was asking for, over the standard deviation of 20. And this is just an equation that we can solve. Okay? If you do solve it, you'll end up with an answer of mu equals 181.